Alright, if you would please go ahead and get out your notes from yesterday. We're going to work the first two practice problems on the back side of your notes. You're going to need a calculator, so go ahead and get your calculator out. And yesterday, if you'll remember, we talked about the conservation of energy, the law of conservation of energy, and how that relates to work and the total amount of energy in a system at any point in time. The mechanical energy, remember, is the combination of both the potential energy and the kinetic energy, and those energies transfer back and forth as an object moves, whether it's a falling object or in this case it's going to be a little roller coaster. And so we're going to use that law of conservation of energy today to calculate some of these problems. Alright, so this first one says a 33 kilogram cart rests at the top of a hill. If the cart has a potential energy of 4,800 joules, what is the height of the hill? So we want to know height, it's a question mark here, and go ahead and write in the potential energy equation, mgh, where m is mass, g is gravity, and h is height. And so if we read carefully, we already know the potential energy, we know the mass, we know gravity, so height is the only unknown variable. Okay, so go ahead and plug in your numbers. 4,800 joules equals the mass of my cart, it's already in kilograms, times 9.8 times h. Okay, so first thing we're going to do is multiply our 33 by 9.8. Okay, you should get now 4,800 joules equals something close to, I'm just going to round, 323 times h. And now what do? We divide by 323. Okay, so go ahead and do that, and you get a height. Okay, hopefully you get something close to, if we round up, we're going to get 15 meters. Okay, easy enough. So this height, this initial height, is 15 meters. Okay, so part B says when the cart has reached point B, height of 5 meters, what is its kinetic energy? Okay, so if at 5 meters, there are a couple of ways to solve this. I'm going to just highlight that part B as now my height is 5 meters. So we know that at 5 meters my total energy still has to be 4,800 joules. So if we come over here, we're going to look at finding the kinetic energy, and we know that that's 1/2 times mv squared. Okay, well we don't know the kinetic energy and we don't know the velocity, so we have to kind of figure out where we can go from here. So hopefully you're going to figure out that we can solve for the potential energy at this location because we do know the mass. Okay, the mass is 33 kilograms. We know gravity, 9.8, and we now know the height, 5 meters. So we're going to find the potential energy at this location. So go ahead and do that. So we're going to take our 33 times 9.8 times 5, and we get 1,617 joules. Okay, so what does that tell us? Does that allow us to figure out the kinetic energy? Yeah, sure. How are we going to do that? Just like we talked about yesterday, the conservation of energy. We know that the potential energy plus the kinetic energy has to be equal to 4,800 joules. So that means my total mechanical energy minus my potential energy is going to give me my kinetic energy. Okay, so I'm going to do that. I'm going to take my 4,800 joules minus my 1,617 joules, and I get 3,183 joules. We could even go a step farther here, and we could find out how fast it's going at that point. So if we wanted to do that, we don't have to do it here. But if we wanted to do that, and we wanted to know velocity, then now we know kinetic energy is equal to 3,183 joules. So we can set that equal to 1/2 times the mass of our cart times v squared and solve for v. So you might be asked to do that in some of your problems today. So just be aware, some of these are going to be multi-step problems. Okay, so let's take a look at the next one. It's also an image, and this one's a little more straightforward, but we're all not going to be solving for velocity here at all either. But just make a note that it is possible to do that. Okay, so again, we're going to be looking at the law of conservation of energy, and note up top, sorry about that. So note up top that the total amount of mechanical energy, so we can call it ME, is 100 joules. So at each location, the total mechanical energy is not going to change based on the law of conservation of energy. So if that's true, then my value for A is going to be 50 joules. And if I come over here at C and D, my height has not changed, and I'm moving along a level space. So what's going to be true of C and D? 50 joules here, 50 joules here. This one's a little too easy. Okay, and then at the bottom, same thing on both sides, FG, I, and J. Same is going to be true for each side. What's now true? As the marble drops down the incline, we're going to see that the potential energy is decreasing, the kinetic energy is increasing. And so if we look at just before it hits the ground, our potential energy is going to go to 0, and our kinetic energy is going to go to 100. And we are going to go ahead and solve for the velocity there. Actually, we don't have the height, so we can't do that. But same thing is true over here. At I, my potential energy has gone to 0, and at J, my kinetic energy has gone to 100 joules. Okay, so pretty straightforward. So what you're going to do for the rest of class today is work on these conservation of energy problems that you have picked up. Hopefully you have picked them up. If not, they're in the back, so make sure you have a copy of that. And if we look at the first side, the first page, there's some diagrams there, and you're going to be solving for potential energy, kinetic energy, velocity, height. So again, these are multi-step problems. Just be aware of the information that's provided. Use your equations up top and solve for each one. If you have questions, then you can send me an email. I'll be able to answer you today. But whatever is not finished in class is for homework tonight, and you do still have a quiz tomorrow over energy. So make sure you're studying for that. It will have some problems, some conceptual questions like we've gone over this week, and it will have some vocabulary. Okay, so let me know by email if you have questions. Otherwise, I'll see you tomorrow.